meets the outside world, because in your retina, they're protected by a lens. And here you have neurons in contact with the world. This actually has been the source for some theories on a potential route for neurodegenerative mechanisms. So as you may know, loss of the sense of smell is one of the, if not the earliest sign of neurodegenerative disease. So for example, in Parkinson's disease, there's loss in the sense of smell probably 10 years before any other symptom. But people have failed to make this a diagnostic tool because it's non-specific. So it's not as if you could come to your doctor and say, I'm losing my sense of smell, and they'll say, oh, early sign of Parkinson's, because you can have many reasons to lose your sense of smell and so on. But olfactory loss, again, is an early sign of neurodegeneration. And there's at least one theory, particularly about Alzheimer's disease, suggesting that Alzheimer's may be the result of a pathogen that enters the brain through the olfactory system.
Interesting.
It's not, of course, a mainstream or widely accepted theory of any type, but it just highlights this notion that the nose is a path to our brain.
I think these non-invasive readouts of potential neurodegeneration, such as visual tests, because of the fact that the retinas are part of the brain and loss of neurons in the retina is often associated with other forms of central degeneration, Alzheimer's, Parkinson's, et cetera, as it's a little more invasive than what you're describing. I'm beginning to wonder why we don't have a olfactory task every time we go to the doctor that would allow tracking over time, because of course, as you mentioned, someone can lose their sense of smell. Does that mean they're getting Alzheimer's? Not necessarily, but if their sense of smell was terrific the year before and it's 50% worse the next year.
That's a really bad sign.
Yeah, that's a bad sign. And so what we're talking about is something completely non-invasive and could be relatively pleasant to innocuous, right, depending on the odors used.
So first I can answer that, right? And the reason that that's not happened, and that may be changing right now, but the reason that has not happened is because olfaction has not been effectively digitized. Right. So if you need to generate, really precise visual information, you can buy a monitor for, $100 that is at the resolution of the visual system, basically. And if you want to generate auditory stimuli really precisely, then you can buy an amplifier for, maybe a bit more than $100, but not that much more. And you'll be at the resolution of the auditory system. In our lab, we build devices that generate odors. We call them olfactometers, which is a misnomer because they don't measure anything, but that's what they've always been called. So we call them olfactometers as well. And we've already built at least one olfactometer that cost €250,000, and it's pathetic, right? So it's pathetic. It's slow, it's contaminated. It's nowhere near the resolution of your system. So one of the reasons that's not happened is just the utterly poor control of the stimulus. Mind you, to some extent, it has happened in that there are standard clinical tests of olfaction, basically two that sort of control the world in this respect. The older one is a test called the UPSIT, which stands for the University of Pennsylvania Smell Identification Test. It was developed by Richard Doty in Penn. And it's a test where you scratch and sniff, and it's a 4-alternative forced choice test with 40 odorants. So you have these 40 pages that you page through, and you sniff and smell, and it's been normed on gazillions of tests. I'm always amused by it because so Richard Doty made a ton of money on the UPSIT, but he needed it because he has a habit. He has a NASCAR. Every time we buy UPSITs in the lab, I say there's another gallon of gas into Richard Doty's.
He races NASCAR?
It's not like NASCAR, but like one lower than that. Like, I don't know, like some sort of Formula A or Formula Ford or some. He races a car. And so that's where all the UPSITs went. So I always feel good about buying UPSITs because I know they're going to that good cause. But
keeping him in the fast lane.
Yeah. But so that's one test that's out there and indeed, has been shown as a so there's reduced UPSIT in Alzheimer's and Parkinson's and in a host of other diseases. And there's a European version called sniffing sticks. that Thomas Hummel has developed, and it's basically the same sort of concept of that one isn't scratch and sniff. It's like these pens that you open up and sniff. But those exist, but they're not as convenient as delivering stimuli in vision and audition, and that's why you don't have what you've just suggested.
Interesting.
Another place where you don't have it, which I think would have been even more meaningful, is olfaction is not tested in newborns, right? Where vision and audition is. There's this thing called congenital anosmia, right? Which is being without the sense of smell from birth, supposedly congenital, which is 0.5% of the population.
It's not a trivial number.
Not totally, yeah. But nobody knows if that really is true, because here's an amazing factoid. Guess the average age at which congenital anosmia is diagnosed. And this is a horrible statistic for me, for the way I see the world. But what do you think the average age of diagnosis is for congenital anosmia?
5 years of age.
14.
Incredible.
14.
So most people who are 1/2% of the human population, presumably, is without the sense of smell and doesn't realize that until they're 14 years old.
Well, I don't know when they realized it first, but it's formally diagnosed at 14 on average, which means some of them even later, right?
And right, it's a distribution. What do they suffer?
Yes. So first of all, they suffer socially, and there's a host of deleterious life events associated with congenital anosmia. They die younger. This is work out of Ilona Croy in Germany, and amongst the various things that are predicted by anosmia is shorter lifespan, but things like reduced social contacts, reduced romantic social contacts. It's not a good thing.
And do they lack olfactory bulbs? I'm presuming they have noses and nostrils. There is a condition I'm aware of where children are born without noses or nostrils. Very rare. Yeah, very rare. We won't focus on that because it's exceedingly rare. Yeah.
But they're born with noses and nostrils. And here's the thing, right? We don't know if they're born with olfactory bulbs. Most of them, although not all of them, but most of them don't have olfactory bulbs in adulthood. Or I should rephrase that, have remnant olfactory bulbs, really shriveled olfactory bulbs. But, nobody can say the cause and effect here.
Before we talk about the role of the requirement for olfactory bulbs for olfaction, a very interesting topic in its own right, I'm curious as to whether or not their endocrine system is altered, because as we'll soon talk about, there's a lot of signaling through the nose from between individuals that triggers things, everything from the onset of puberty to feelings of romantic attraction, attachment, these sorts of things. Is it known whether or not, and I should say, excuse me for interrupting myself, but as long as I'm interrupting you every 5 minutes, I might as well interrupt myself too, that we are well aware of the proximity of the olfactory system to some of the hypothalamic systems that regulate the release of gonadotropins, which control testosterone and estrogen production, et cetera. So are they hormonally normal?
So some are and some aren't, and I'll be specific. So there's a condition known as Kalman's syndrome, which is hypogonadic development in men. And in Kalman syndrome, they're practically all anosmic. So to answer your question, yes, there's a direct link, and it materializes in Kalman syndrome. That said, not all congenitally anosmic individuals have Kalman syndrome, and not all, but almost all people who have Kalman syndrome are anosmic. So Kalman syndrome goes with anosmia. I think so. There's a female equivalent of Kalman's, or I don't remember its name.
It's not Turner. It's not in the Turner syndrome family.
I'm not sure.
Okay.
And I think it's also associated with anosmia, but I'm not confident of that. But Kalman's is associated with anosmia. So the answer is yes. And we can maybe, olfaction and reproduction are tightly linked, and they're tightly linked in all mammals, and we are big terrestrial mammals, and olfaction and reproduction are linked in humans as well.
Yeah, we will definitely get into that. I have a story / question that I'd like to ask you as a segue to that. Noting, of course, that we'll get back to the requirement for olfactory bulbs, yes or no for olfaction. This relates to when I was growing up. I grew up at the end of a street with a lot of boys of my age who, just by coincidence, had a lot of older sisters that were my older sister's age. It was fortunate, so I had a lot of kids to play with. We would hang out at each other's houses, bike, build jumps, and do all those things like kid stuff, fort stuff, get into trouble or whatnot. And oftentimes we would end up leaving our articles of clothing at each other's houses all the time, like t-shirts and jackets. And so my mom was constantly coming in and saying, there's this clothes, like someone left this here. I don't know who it was. We were all more or less the same size. And from as far back as I could remember, 6, 7 years old and onward, I could pick up a shirt or a jacket, smell it, and say, oh, well, that's Eric Eisenhardt's shirt, a friend of mine there. I just gave his name. Or, oh, that's Scott Madsen's shirt. I could just smell the shirt and in a conscious way know who it belonged to. Having never, I promise, not that I would pretend pretend I hadn't if I had, but having never actually done the exercise of going and taking and smelling my friend intentionally.
Right.
Okay. In fact, if anything, I had all the reasons in the world to avoid smelling the other young boys in my neighborhood. Okay. So that raises a question of whether or not we are consciously and or subconsciously coding identification of people that we interact with frequently or infrequently in terms of their smell or some other aspect of their chemistry.
Yeah. So yes, we're doing that all the time, in my view, and a lot of this processing, almost all of it, is subconscious, and I don't know why. Already put that out there, right? I have no idea why human nature has or nature or culture or whatnot has pushed this into the realm of subconscious and something we're unaware of. But we do it all the time, and our lab has lots of studies on this front. One of them you may be familiar with that had gained some notoriety because it's amusing. So we look at human behavior a lot. We try to look at it through our nose and in the way we look at what people are doing. We try to think, if I was a dog, what would I think of this? And if you look at dogs, right, they've when they interact, they visibly sniff each other. It's very obvious. They walk up to each other and they sniff each other. And yet humans don't typically walk up to a stranger and carefully sniff them, right? I mean, we're sort of obliged to sniff our babies. That's considered almost something you're supposed to do. And it's not culturally taboo to sniff our loved ones. It sort of doesn't seem like an odd thing to do. But we don't sniff strangers, right? Well, or do we? So we're finding more and more mechanisms where we do this. And the one I'm referring to now, for one example, is we started looking at handshaking. Handshaking is this really odd behavior. And it's not only in the West, by the way, as some people think it's only a Western thing. It's not. It's almost everywhere. And there's really poor understanding of how this behavior evolved. Like where did this thing come from? So if you look for the Wikipedia version, right, then they'll tell you that it's to show that you're not holding a weapon in your hand. But there's really no good evidence for that. It's a bit like the trillion bloodhound receptor story, right? I mean, we tried to find it. Why do people say that? And they just do. And we started looking at people handshaking, and we noticed, or it seemed to us that we're noticing that, people will shake hands and then we'll go like this and like this.
For those of you listening, not watching, Noam is taking his hand and wiping it on his face, grabbing his nose or
touching
the
myself.
side of his cheek.
These things that we do all the time.
after a handshake?
Well, so first of all, we do them all the time, just period, right? The baseline here is really high, and we'll get to that in a second. But these behaviors that you could easily not notice, right? And so we asked whether that's a real thing. And this was a study led by Idan Frumin in our lab at the time. And what we did first, and if you want, we can link. So this was published in eLife, and one of the nice things about eLife is that it has a very effective way to embed videos in the publication. So if you want, we can link this to your system later on.
We'll put it in the show note captions as a link on YouTube and the other four platforms, Spotify, Apple.
So what we did is we brought in participants to our lab, and we sat them in the room, experiment room, and told them the experiment would start soon and they should wait for us there. They didn't know what they were coming from. Unbeknownst to them, they were already being videoed. Of course, later on, they had the opportunity to not agree to us saving the video, in which case we would delete it immediately, or letting us use it for science, or some letting us use it for more than science for the video that's now on eLife. And we would walk into the room and say, okay, just wait here. We'll be right back with you to set up our experiment. And they would sit there for 3 minutes. And during those 3 minutes, we could later quantify how much indeed they, just by baseline, how much they touched their nose or their forehead or their chin, or how many times their hand reaches their face. And by the way, that baseline is not low, okay? And then 3 minutes later, an experimenter would walk into the room and would share a consistent text. It would be, we're still setting up our equipment in the other room, and so just wait here and we'll be right back with you. But in the meantime, just wait here. And the experimenter went through this 20-second fixed text. And in half of the cases, it included a handshake. This was a new experimenter, not the one who put them in the room. So it's the first time they met. So it would be, hello, I'm, so-and-so. They would put out their hand and shake their hand or not. Okay, and we did all possible interactions in terms of gender. So we matched male participants with male and female experimenters, and female participants with female and male experimenters. And so you had handshake and no handshake conditions. And then you can quantify that behavior of the hand going to the nose after handshake. And there was a remarkable increase in the hand going to the nose after handshake. And this is one of the nice cases. The paper includes statistics, but you don't need statistics here. Just look at the video. It's unreal. The video is unreal.
So interesting.
So the hand goes to the nose. Now, we did a few controls here to verify that this is an olfactory behavior. One is, unbeknownst again to participants, we measured nasal airflow. And people not only bring their hand to their nose, they sniff it. So, and this is perfectly timed. They go like this, okay? So they're sniffing their hand. And in an additional control study, we manipulated it. So we built this little James Bond thing of a watch on the experimenter's hand that could emit an odor. And the experimenter didn't know what odor they were emitting, and they could emit either a pleasant or an unpleasant odor. And we could drive the self-sampling afterwards up or down. So this was an olfactory behavior, no doubt about it. I mean, we're quite confident.
So people, in that case, people must have been sensing the odor on their own hand because they had shook the hand of the experimenter, pleasant odor, and they're more frequently bringing that hand to their nose versus unpleasant odor that had been introduced to their own hand by the experimenter. Correct?
Yeah, but no, I think they were sensing the ambient odor that came in with the hand that shook, and then that either drove them to sniff their hand more or less.
The odor cloud of the experimenter.
Yeah, and there's an interesting thing going on here too, because people didn't only smell the hand that shook, they also smelled the other hand. And we think that there's something going on here comparing self to other. And we think a lot of self-sampling might reflect that. There's on the same line, and again to link to your childhood story of identifying your friends by smell, a study we published just last year by Inbal Ravrebi in our lab, where Inbal came with this basic interest in this phenomenon that's loosely referred to as click friendships. So people you meet and you click right away, right? You immediately become close friends. And this is a phenomenon that is poorly described or is poorly described in literature as an entity, and yet anybody will tell you they know what you're talking about, right? I mean, if you tell, if somebody you click with right away, you become intimate within 5 minutes, right? Everybody experienced this in their life, to some extent. And the question is, what was there, right? What was it? Was it because you looked the same? Could it be, was it because, you had the same sports team that you liked? Or is there something deeper here? And Inbal's theory was that a similarity in body odor may contribute to this. That people who smell the same will click in some way. And so to address that, she actually recruited click friends from all over Israel. She posted all over social media to identify pairs of friends. So these are same-sex, non-romantic dyads. So these are friends, men and women, whose friendship started as a click, where here this becomes sensitive because it has to be a mutual click, right? Later on, we discovered there could be one-sided clicks. So if somebody's sure they clicked with somebody else, but the other person...
There's a name for that in neurology that our common friend, the late Ben Barris, taught me, which is there's a phrase that neurologists use called sticky. These are people that come up to you and start asking you questions and then won't leave you alone. They're so-called sticky people and if you ask these sticky people, sticky in air quotes because they're not physically sticky.
They may be.
What they could be. What do you think of this person? They'll say, "Oh, they're great. We're really good friends." And so they've made a unilateral click friendship. And yes, neurologists are talking about you. If you're one of these people, neurologists are talking about you. There's an informal diagnostic code, sticky.
So she recruited click friends, and then she sampled their body odor. And we have a protocol for this. So they're given, odorless shampoo and soap to use for 3 weeks or something. And then they sleep 2 nights in this t-shirt where they have to sleep alone. And then we extract the body odor from the t-shirt. And so we have a way to extract, a method to extract body odor. And then she first asked whether indeed click friends are more similar in their body odor than you would expect by chance. And she first tested this with a device, a machine we call an electronic nose. So an electronic nose is sort of a very poor effort to mimic what the mammalian nose does. Basically, it's a bunch of sensors that respond to airborne molecules. In this case, sensors referred to as MOXers, as metal oxide-covered sensors. And so she used an electronic nose to sample these body odors. And she found that click friends are indeed more similar to each other than you would expect by chance, by random dyads. And this was a significant difference. And after she found that a device could do this, she had other participants do this. So she had people smelling the click friends versus non-click friends, and they judged them as being more similar to each other than not. Now, again, you might wonder, is this causal or not, right? Because maybe click friends go to the same restaurant together or all the time or whatever, or live in the same neighborhood, and that's why they smell the same. So to address causality, she recruited total strangers and first smell them with the electronic nose, and then engage them in a social interaction, something called the mirror game. So in the mirror game, one person moves their hands and the other person is really close to them, like right here, so they can smell each other, and has to move their hands with the other person. And one prediction there panned out, but another didn't. The one that didn't, so she predicted that people who would smell more similar to each other would be better at the mirror game. That is, they would follow each other better. That did not pan out. However, she then also had, the interaction was completely nonverbal. They were not allowed to speak with each other, and she did an entire round robin, so everybody played with everybody else. This was an insane experiment to run. And she then, at the end of the experiment, each person rated each other person as to how much they think they would want to be their friends, and also on a bunch of ratings, how nice they think they are, how affectionate they think, a bunch of ratings, okay? All of this was predicted by the electronic nose. So people who smell more similar to each other think that the other person is more likely to be their friend, is more likely to be a nice person, et cetera, et cetera. So we could actually predict friendship using the electronic nose. So this is not a result of friendship. It plays into the causal elements of building friendship. So this is to relate to your childhood story. There's something going on here. We're constantly smelling ourselves, constantly. This constantly. I mean, if you want to link, I'm now the reason I'm smiling. I mean, and your viewers or listeners will understand why I'm smiling. I'll send you a video to link into your podcast here. We thought of calling the fact that people constantly sniff themselves. We thought of calling this the Lowe effect, and Lowe. So in America, this won't pass that effectively, but in the rest of the normal world, Joachim Lowe is the national soccer coach of the German soccer team. So, I mean, I don't know who would be a very famous coach here, but Steve Kerr. I mean, this is this is a super famous name all around the world where soccer is the primary sport that people watch. And once people will see this video, they'll understand why we thought of calling this the Lowe effect. It's very graphic. But people are constantly smelling themselves. They're smelling themselves with their hands. They're smelling themselves explicitly. People are constantly smelling themselves, constantly smelling others.
I find this topic so interesting. And first of all, confession, I definitely smell myself multiple times per day. And
everybody does.
Okay, good. Well, then I would do it anyway. I think I, like most people, I either find my own smell to be neutral to pleasant, right? Occasionally I'll be like, whoa, I need to take a shower. As long as we're talking about smelling oneself and friendship, kinship, and its relationship to smell, we have to talk about the relationship between smell and romantic attraction and bond. So my understanding is that if, for instance, a mouse is given the option to mate with any number of other different mice, they will bias their choice toward the mouse that has the immune composition, the so-called MHC, major histocompatibility complex, which reflects immune diversity, the immune system that is most distant from theirs. And the evolutionary argument being that were they to produce offspring, that the array of immune genes would be much broader than if they were to select an animal very close to them. And in addition to that, that one of the most strongly selected against behaviors, not just culturally, but at the level of eliciting a sense of disgust, maybe even from the activity of the hypothalamus, is mating with very close kin, aka incest, because that can potentially, we know, produces a higher rate of mutations. In other words, whereas you described the relationship between smell and choice of friends as you choose people who smell more like you, my understanding is that in the context of choosing romantic partners or sexual partners or both, that you choose the person whose odor and therefore immune composition is most different.
Right. So the way you describe the animal literature is correct. And there's evidence to similar mechanisms in humans. Our lab has not worked directly on this issue of romantic selection based on odor. There's a bunch of papers, Wedkind et al. In the Wedkind lab, and also Porter, I'll email these to you later on, that have done a lot of this work and find exactly, as you say, that romantic odor preferences in humans are influenced by body odor, and that this is linked to MHC, histocompatibility complex makeup of the portion of our genome that shapes our immune system to some extent. So this effect has been studied and reported on, again, extensively in mice and also in humans, not work that we've done.